Hey guys, welcome back. You guys asked for it, so I'm here to deliver. That little cool Paper2D character that I posted as my last video got a massive reception on Facebook. I was a little overwhelmed about it, to be honest. And a lot of people asked me how I did it, and I'm here to explain. So there's not really a lot that went into it, to be honest. There's the Paper2D character, there's the environment, some camera stuff, a little bit of fog, and some Gaussian blur. And really, the only thing you're going to need to get started is just a character base sprite sheet. Now, just a quick note on copyright. You obviously can't just go and rip someone else's sprites out of their game and use them in your own project. But there are loads and loads and loads of these custom sprites that you can search online. You can go to DeviantArt and just search up a custom Pokemon character. Ask the author if it's okay to use them in their game. I'm almost certain that they'll be okay with that. They love that kind of thing. So this is just the one that I picked for the video. It's just got the 4 directions of walking and the 4 directions of running, so that we can get the basic sort of motion going with the character. And that's really all you need to get started. Once that's in the engine, I mean, I've already done this with this file, just right click it, come up here to Sprite Actions, and apply Paper2D texture settings. And that's all there is to it. That clears up this background and it sets your pixels right, so we get that nice clean pixel edge around the graphics. And then you're ready to go. The next thing you want to do is right click it, and at Sprite Actions again, we're going to go to Extract Sprites. And there are a couple ways that this can be done. So by default, it's going to just try and automatically isolate all of these little sprites here, but that's not quite what we want. They're all going to have slightly different dimensions and sizes. So instead, we'll set it to grid, and we can see here via this yellow outline how this is going to go. So our cell width and height, we're just going to dial this in. We're going to find the right dimensions. So 27, I believe, is the number of pixels in X and Y, and then the number of columns here. So if we change the number of cells in the Y-axis just to 2, there we go. So these are our sprites, all isolated and ready to extract. And once we hit extract, just this little green button down the bottom, it's going to pull out all of these sprites into their own little files, which we can open up and have a play with here. The next thing, and the reason that this is coming up as black, is because, so you might have noticed that I'm using the same project as the one I made in the video. So over here, we see the material that makes up the sprites, right? This is the basic sprite material, this masked unlit sprite material. If we open this up, we can see that it's just an instance. So we'll have to find the parent, click this little magnifying glass here by the parent material, and open up the default sprite. We'll drag this up, and as we can see here, let's just get rid of this. So all I've done is I've added a scalar just to set the roughness down to 0, and I've also moved the source texture here, the sprite texture, from the emissive up to base color, so that it actually gets lit by the scene. And this is so that the sprites can actually react to sunlight and be shaded and that kind of thing. Sort of allows them to be lit. With that done, we can head back up. Oh, by the way, so if you can't see this, remember to enable engine content by clicking down here in View Options. Let's so just enable all of this. So the plugin content, the engine content, the C++ classes, enable all of this, and you should be able to navigate to your Paper2D files and affect the base sprite material. So then, back at our character, next thing we have to do is to sort out our animations, which is done using a little tool called Flipbooks, which is literally what it sounds like. It's flipbook animation using 2D images. And we're going to need quite a few. So, for example, this is just our standing pose looking forward. So we'll right click, go to create flipbook, and we'll call it anim idle. Actually, we'll go the other way around. We'll go idle down. Yeah, that'll do. So just idle down. And that creates a flipbook file, which if we open up, it's just going to loop this one frame. So it's just going to stand still and face towards the camera. So let's get these 3 frames. So this is our walking animation. Right click, head to create flipbook. This will be our, we'll call it walk down, and open that up. So here we see, you know what, just for ease of, just to pretty this up, I'm going to come back to our material here. Just move this back to emissive so that we can see it. Just wait for that to save. And there he is. So let's just have a look here. So obviously right now, well, for one thing, the frame rate is way off, and the frame ordering is also off. Let's change our frames per second down to something like 5. So that gets a slightly better walking pace, but now the So the frames are rough. He's not stepping quite right. So we need to take these frames here. Let's see, where are we? We'll drag this around, have a little scrub. So we need the facing frame in between 1 and 2. Let's duplicate that frame. I'm just going to drag it up to the end here. A lot better. Now if we hit play, there we see our walking animation. And that's it. That's all we have to do. So we have to set the frames per second to 5 and add that extra frame in there. And we do a similar thing with the running frames. So if we come back up here to our character, where are we with our... Okay, so here's our running down animation. Let's grab those 3 frames, right click, hit create flipbook, and we'll call it run down. And we'll open this up and do something much the same. So if we set this to 5, and then just like before, duplicate this frame and just drag it up to the end here, and we can scrub along and sort of tinker with that until we get the ordering of our frames just right. Then we hit play, and there is our running animation. But of course, running is faster than walking, so we can set our frames per second up here. We'll double it. We'll make it 10. And now he's going to run at a quicker pace that he's going to walk. Very cool. So hit save on that, and we're ready to continue. So we'll close that flipbook. Now you're going to want to do this with all of these animations, so that you get the every animation state that we can play with in the blueprint. So what can I do with this? How about like a daydream transition? Can I do that? Just like that, we have the idle, walk, and run animations for all 4 directions of movement. Pretty cool, if you ask me. So we got all 4 directions. In fact, now that that's all done, let's head back to our main... where is our... to the default sprite material. Yep, let's just move our emissive color back to our base color so that we get our lit textures. Hit save. And now we can build up our character. So let's go back to our editor. And here we are. In fact, let's make a folder here just so we can store some of this stuff away. Call it Sprites. Grab our texture and all of our sprites and dump them in that folder. Right. Well, that works. Cool. Okay, so let's make a new blueprint class. This one will be in this all classes search bar. What we want is a paper character. Ooh, paper character, hit select. We'll call it Paper2D _ character. Alrighty, and the next thing we want to do is also we'll make another blueprint class, but this one will be a game mode, and we'll just call it our paper game mode, or paper GM. Oh, wow, did I misspell that? Never mind. Because this will be our game mode override. We're not going to use a default pawn class. We're just going to use a spawn blueprint, like a blueprint spawner. So if we scrub that out, oh, we could edit it here, I guess, but that's okay. So with all that done, we can, what's first? Now we'll make the spawner first. So the spawner is just going to be a regular actor, and we'll call it spawner BP, and it's just going to handle where the character is and how it's going to be created in the world. So we'll open that up, drop it here, and there's really going to be nothing much to do with this. It's just a little tool here. So we'll go to our not construction script. We want the event graph, and we want our begin play, and we're going to come off this begin play to spawn our original actor. So down here in variables, make a new variable. Call it our character, just like that, and it needs to be a paper character. Paper2D character, I believe that's it. Class reference. So we'll compile it so we can get our variable, drag this over, and set this character as our Paper2D character. Very nice. And we come straight out of here into a spawn actor. Where are we? Spawn actor from class, that'll do. And plug it into our begin play. So we're also going to need to split this transform struct pin so that we get access to these different little pieces of data, our location, location, and scale. And let's also get this actor's transforms. All good. Let's split this one though, because we're not going to use all of them. We're going to have some extra control here. Get the location and the rotation though, so that it's in the right spot and it's facing the right way. But then let's make another variable here, call it the player size. So as we'll see, once we start mucking about with cameras and spring arms and field of view, that kind of thing, we're going to need some control over how big the player appears in the frame. Make it a float, hit compile, and set it to 1 for the time being. Drag this in, and we want to make this a vector, so just drag it into scale and it'll do that for you. And we're done. And then out of this spawn actor node, let's come over here, make a possess, and we'll need to get the player controller. That way, what have I done wrong? Controller. Get player controller. This will be plugged into the target, and the end pawn is obviously the result of our spawn actor. And that does our spawner, so we are finished. Hit save, we'll leave that. I'm going to close some of these tabs, make some space. And now, let's open up our Paper2D character and have a look here at some of the things that we can do. So, we've got a sprite component over here, which as our source will make our idle down. That's the wrong one. There we go. This is our little idle down guy. And we'll also need a camera so that we can see him. Grab a camera and a spring arm. Alright, now the camera has to be a child of the spring arm, and then the spring arm will control how the camera works. So we'll just orient it properly so that we know what we're doing. This blue arrow is going to be the forward direction of our player, so we can orient our components here in relation to that arrow. Drag things around. Alright, we'll hit compile and save just initially, and we're going to want to make our little sprite guy a little bigger in the component here, so he sort of fits out in the capsule a little bit better. And speaking of, we can drop him down just slightly to make him a bit more central, and then adjust the height of our capsule so that our collision should ideally work with the size of our player. Just make sure that he's central here, a little bit like that. That'll do for the time being anyway. And then adjust our spring arm. Let's make it it'll need to be quite long. Set it something like 1200, and the camera perspective is the right view that we need, but we want the field of view to be dropped down to like 50. Cool, and that sets our camera up quite a distance away, but our spring arm here will, because we can't look directly at, like flat, horizontal at the player, because it's not going to look good once we're in the world and once it's, you know, oriented in the way that we want. So we're going to have to rotate our camera up, just 10 degrees should be plenty. And then in the construction script, because we don't want any sort of distortion on screen for when the player and the camera sort of aren't aligned properly. So we can fix that here in the construction script. And the way that we do that is by dragging in our spring arm, and we'll get the world rotation, just like that. And we will also get our, where's our sprite? We'll get our sprite in just for the time being, drag off the construction script, and set the world rotation. Set world rotation. Oh, it's going to do the component for me. That's all good. So then all we do is plug in our world rotation from our spring arm into the sprite. Although we don't need all of the rotations. So in fact, we'll split both of these because we just need the Y value, just the pitch. We'll drag the pitch, hit compile, and then back in the viewport we can check, and we can see that there is an issue because it's oriented sideways, which we don't want. So back in the construction script, which direction was that? It's the Z-axis. So in the construction script, we'll change this -90. That should rotate it back around to the right. Yeah. So now he's sitting pretty, although he's not rotating with the spring arm, which is odd. We don't plug it into the Y rotation of the sprite. We need to set the X rotation of the sprite. So just grab this guy and put him in the X. And if you want to learn how to do that, you're just holding control when you grab the pin, and you can just move him around. So with that set, now he is, or should be, what now? We have to compile, and now he's set. So with the construction script compiled, we can see now, kind of, that the character is now rotating with the spring arm, and we can check even further. So I've got the spring arm selected, and we can rotate it like this, and the player is always going to match the orientation of the spring arm. 10 degrees should be plenty. We'll compile and save back in the editor. we can drop our spawner into the world, hit play, and there we have a Paper2D character in the world. Of course, there's nothing to it at the moment. We need to set some other stuff, get some controls working, and we'll do that next. So for adding controls to the character and making him move in the 4 directions that we want, let's go up to our blueprint here, hit the character movement, and we need to set our movement details over here. So our default land movement, which we'll find in the general settings, has to be set to flying, because we don't want it to go. We don't want a platformer. You know what I mean? We don't want a 2D side scroller. We want a 4-directional sort of character movement. So we set it to flying. We don't need to do anything else here except we'll change the speed. So we'll go down to flying. We want our maximum fly speed. We'll set this to 300, something fairly low. And our deceleration, the braking deceleration, really, really, really high, so that he can stop. And we don't get that sort of. So it doesn't look like he's skating around, you know, with no friction. So just compile that, and we're ready to also get on it. So let's head up to Edit, then Project Settings. We need to make sure that we have our control axes set in our project. So up here in Input, I've got X-axis and Y-axis here. So X-axis is A and D, Y-axis is S and W. I've also got the move forward and move right, but I'm not using those. This is just for our Paper2D character. So A being left, scale of 1, D is right, scale of -1. S down is -1, while W up is 1. This is all we need to do. So once those are set, we'll close that and come back here, and we can start on making our controls. And really, it's pretty simple. So let's go to the event graph. And here, we'll ignore this for the time being. In fact, we'll just delete. Let's right-click, and we get our input axis. We want our X, and we want our Y. Boom. Then, coming out of each one of these, we want to add movement input. If I could spell properly, add movement input, and set our world direction vis-a-vis how the character is going to go. In fact, we'll just duplicate this, plug it in. So in the case of the X-axis, we want to be affecting, obviously, the X-axis. So we'll set this to -1, or we could change the ordering in the project settings, but -1 will correct it with the orientation of the camera and make sense for the player. And the Y-axis, obviously, is the Y-axis. We'll set to 1, because up and down will always be up and down. And plug in our axis value into the scale value of each one. And this will give us basic controls. So if we hit play, so we're a little bit backwards. So my up and down is sending me left and right, and my left and right is sending me up and down. So easy fix for this. In fact, it's going to look a little strange, but this gets the controls working. Again, this is a project that I made sort of in half a day, so there are a few things to iron out. We've compiled that, so the X and Y are a little inverted. That's better. So now my 4 directions are working exactly as intended. In fact, while we're here and while we've got some motion going, let's just drag our character into the world. And because we can see him all lit like that, where's our directional light? Because it's currently facing sort of away from the character, and we don't want that. We want some light to shine on him. So we'll rotate our directional light, click the sky, head to details, press this button here to refresh the material, and that will correct the sun. So fix where the sun's coming from. All done there. So now if we hit play, okay, he's better lit, and we're walking around just fine. There's no animations yet, but we can do that next. So the first thing we're going to want to do is right-click here, come down to, I think it's in miscellaneous. Perhaps not. What we want is an enumeration. Okay, and we'll call it, we'll just call it set dir. Open it up, and let's make 4 of these enumerators for each one of our directions. This is how we'll let the blueprint know where the character's facing and which animation it should use. So just make all of these, name them something sensible, up, down, left, and right. And we're done. Our enumerator is finished. And now, back in our paper character, let's make ourselves a new function, and we'll get to implementing it. So we'll call it set direction. This, or in fact, yeah, set direction is fine, doesn't matter. So here we are in set direction. Let's first of all just grab ourselves a branch. We'll come straight out of here into a branch. Now we need to check whether there is input coming in. Let's just get our x-axis and our y-axis. Boom. And we need to check if these are actually being affected. So exclamation mark equals for a not equal. We need a not equal float for each of them. So if neither of them are equal to 0, we can do some things. And if they are 0, then we can do some other things. This is so that we can tell, because they're going to be 0 if there's no input going into either of these axes. Come out of this here into an OR. So it's so if either one of these is not 0, we can do things off this branch. And that would be to set our direction. So over in the variables, to make a new one, call it direction. And this will be our set dir enum. Compile that so that we can use it. And let's drag him in, alt drag, so that you can get the set. And if it's true, we'll just set our direction. If it's false, we'll do some other stuff a little bit later. But for now, what we need to do is figure out which direction the player is facing. Let's duplicate both of these, our get x and our get y axes, and we're going to need a select as well. So select and our direction. Well, actually, we can come straight out of here, I think. If we do that, yes, although I don't like that there. So we use a boolean. So here's our get x. Let's come out of here into a greater than. Float greater than float. Yep. So if our x-axis is greater than 0, then we'll set our direction like this. So make a select node. Select, and this will be our direction, which we'll plug in from over here. So let's see, what do we got here? So if the x-axis is greater than 0, that means if it's true, then that means we're going left, and if it's false, that means we're going right. Pretty simple, because this just corresponds with the 1 or the -1 from our project settings. And then out of here, we'll need another one of these selects so that we can come into the false. So if it's false, yep, we'll move forward. So get y-axis into a less than. Float less than float. If this is less than 0, then we set to down. And this is the simplest way I've found to do it, is that if you come out of this select to another select, duplicate these guys, or just the get y actually, and we'll use this one a greater than. If it's greater than 0, then we're facing up. That's all done. Plug that into direction, and we're ready to move on. What's next? So false. We'll come out of here and we'll set our flipbook. Select our sprite flipbook. And what are we going to set that as? Well, we have to check for the direction. So let's grab in our direction. Let's get that. And we'll come out here into another select. A select. Up, down, left, and right. The return value will be the flipbook, which will change all of these here into our flipbooks. Okay, so far so good. What's needed next? Oh, okay, so sprinting, so running. Let's just sort that out while we're here. First thing, we'll need a variable called isRunning. Make it a boolean. Compile, and we're good. Then let's get the shift key. Left shift, and all we're going to have to do here is just set this boolean here based on whether the shift key is down or not, and then change the speed of the character, which is pretty easy. So we'll drag in our character movement component because we'll need to be able to get our max fly speed. Set max fly speed. We'll need 2 of these. So one to be set when it's pressed, another to be set back when it's released. And if remember what value we set in the character movement, that would be 300. Maximum will be 600 or 750? 750? Let's have a look at our character movement, what we set it at. Pull down here, max fly speed at 300. Yeah, so when running we're at 750, and when released we're at 300, back at walking speed. So, and then when pressed, we are running, and when we let it go, we are no longer running. Easy enough. Let's go back to our set direction function, and we'll continue building this out. So first thing is, out of this set here, we're going to need to get ourselves another branch to check for if we're running. We'll drag this in, we'll get it, plug it into our branch. Done and dusted. Let's put the false into this playbook, and the true. We'll set some more flipbooks for if we're running. Come on, plugged in. Plug in our sprite as well. And let's see down here. So here's our direction. Let's duplicate this as well. because these two are going to make up our idle and our basic walking. And the way we'll find this is by just simply getting the velocity of the current actor, of our player actor, as this vector here. We'll get the length of the vector length, and then check to see if we're moving or not. So, float greater than float. If it's above 0, we'll be able to select based on that. So, we'll get our select node. If it's false, we'll be idle. And if it's true, we'll be moving. This means we can start setting up our flipbooks. So we'll need, what do we got here? Idle up, so I've got a lot of these. Idle up, cool. And idle down. This is slightly boring. You know what I might do? How about another one of those daydream transitions? That seems to speed things up. Wow, you know, it's just amazing what modern technology can do. So now that we've set up our idle and our moves, we can work on getting our running done. Well, first of all, out of this this true-false select, this goes into our new flipbook. So these are just setting what we're sending into this flipbook node. And then furthermore, we'll need to do a similar thing for if we're running. So back up here at this branch, let's just make ourselves a little more space here because it's starting to get a bit crowded. Drag some of this stuff out, just like that. So as you can see, this is our check for if we're running. If we're not running, we come into this flipbook, which is being set as idle or move. And this flipbook is our running flipbook when we are running. In order to do that, let's grab our last direction. Just get it. And another select, another one of these. I'll grab this one. Plug that in. And we'll select on each one. So we'll just set our run run flipbooks, and then get ourselves this select node again and plug that up over here. This will be the true. So set that in our coming out of our velocity check down here, and our false will be the idle. So this is our idle select. So this checks so that, okay, if sprint is down, if we've got shift down, but we're not actually moving, then it's not going to play a running animation. Hopefully that makes sense. And then we'll plug in the result of this select into our new flipbook. Done and dusted. All set. So this should work just fine. Let's hit compile, hit play, and look at that. Perfect sprite-based animation. Here's a little bit skatey, but you can set that braking friction in the player settings. But this is all done. So I hope that made sense to you guys. So we're just checking for our axes. We're also doing a couple of velocity and direction checks, and setting flipbooks based on those different conditions. That's all good. We have one more function to make first, because in order to make this, like our little guy here, work on like properly in the 3D world. In fact, I'll see if I can show you something here. So if we find some starter content, I'm just going to find a shape and get a cube. Put a cube in. I'll make this a bit bigger. So here's the thing about the current setup we have with our character. So we have this set up just like this. He's going to walk up the slope, but then when he hits the edge, he's not going to drop back down to ground level. He's just going to stay up, sort of floating up in the air. And we don't want that. We have to recalculate his Z location. So let's make ourselves a new function. This will be calculate Z, and we'll just use this one to make sure that whenever he's higher than ground level, he can come back to ground level with no trouble. So to get started, let's just drag out of here. We'll make ourselves a line trace by channel, and set our start and end directions, locations. Well, obviously the where am I? The get actor location. This will be the start point of our trace, and let's duplicate this guy, split this pin, and where are we? We want to make vector. Make vector. There it is. Come out of the X and the Y, just as normal, but come out of the Z. We want to subtract. So float, subtract, float. We want to take off, let's say, 200. It's a fairly arbitrary number, but this just ensures, once we plug this into the end location, that this line trace is going to be fired straight downwards. And we can double check to make sure that it's working. Let's set our draw debug type to full duration, hit compile, Back in the map, I'll make sure that we're calling it, obviously. So here's our event tick. Grab our calculate Z, plug that into our little train, hit play, and here we can see, yeah. So there is our line trace. So our line trace is hitting the ground just normal. So we're finding the ground level, which is a good start. Now all we have to do is move our player to readjust. So let's come out of here into a break. No, that's not what we want. We want the out hit and into a break. Why is this a... Oh, that's a multi-line trace. I got the wrong one. Come on, where are we? Line trace by channel. There it is. Let's hook these back up. Just like that. And our out hit will come out into a break. And then all we're going to need is the impact point. So we'll split the impact point because we just want the Z location. So out of the line trace, we want to set the actor location. Hope this is all making sense so far. So we're firing that line, and we're going to break it and set the location of the actor that is our player. Come out of the impact point, our Z, let's, just like this, we're going to add this to another value, and that value is going to be our distance from the ground. So we'll make a new variable, call it distance, call it distance Z, and make sure that we set it to a float. Hit compile so that we have access to it, and drag this into the world. In fact, we'll set this to something, I think my value was 51. I think 51 units is what we want to do. We're going to add 51 units, so that's the middle point of our character. So if that doesn't make sense, so I'll just explain why it's 51. Is it relates to the size of the player. We don't want it to go straight down to 0 to the actual Z point of where this line trace ends, because that's literally ground level, so we'll be like half in the ground. We want to find that Z point, and we're going to add some more to it to get us up a little bit more, so the player sort of makes sense on the ground. With that done, let's get another actor location. Let's steal this one. Just like that. Oh, and also the make vector. And put in the X and the Y. And we'll... that's not right. Oh, yeah, yep. And the result of this plus into the Z. And the return of this vector into the new location. And this will set the Z value. So if we hit compile, go back to the editor and hit play, we can see now that he drops back to the ground once he falls off the slope. And he won't climb up the steep slope either. Very cool. So now we can have variable terrain, we can use our landscape mesh, all kinds of cool stuff. And this pretty much wraps up the functionality for the player, which means we can get onto the fun, pretty stuff and make the pretty environments. So let's clean this up. We'll hit save on everything and get ready to go. So let's change our mode to landscape. I'm going to tear this panel off so that we can see it a bit more clearly. Just like that. So we've already got our landscape material here. Let's just set our layers. If you'd like more info on the landscapes, check out one of my previous videos where I made a landscape. And we did some texture painting and some sculpting, that kind of thing. It was lots of fun. Set our sections to 2, our components to 4 and 4. With some nice optimized landscape. And then we'll just hit, and probably put this back at 0. And then we'll hit create. And then we have our landscape ready to go. So now we can paint on it and stuff. Let's we'll paint on some desert. Cool. So we got some different things to walk on. The only real difference that I've made here between my original landscape material and this one is that I added the sort of pixelated stylized effect to the materials. So let's just put this back over here. And over in the content browser here, let's open up the landscape material and I'll show you what I did. So here's the original material, which is fairly straightforward, just some layer blends and that kind of thing. But it's over here in the final base color where I've used a noise mask, and I've applied the same sprite, the 2D sprite things. That's where you remember when we do I have it in this folder? There it is. We right click sprite actions and then apply the 2D texture settings with the nice clean crisp pixels, and just multiplying it by scalar, using a clamp here to control just how much of it, and then a blend overlay to affect the whole thing. And that's all there is to it, really. Now that if we hit play, here we go. And our little player, a little guy, he can walk up slopes and stuff that I've just quickly sculpted in, and he won't get clipped or anything, and he won't float away into the ether. With that all done, what's the other thing that I did? So foliage, Foliage I did in much the same way. So if we open up, which one is it? Just not the foliage material. It was the tree trunks that I did too. Where are we? The tree trunk. It's literally the exact same code. It's the noise mask with the scalar, the clamp with the controls here, and a blend overlay to affect the original base color. Close that. We'll go to our foliage tab, and I'll tear this off. Just like that. So we've got some foliage to play with. Where are you? So we'll just drag in these two for the time being, I suppose. Paint in some trees. That is way too many trees. So much like the landscape, if you'd like more information about my about these the foliage meshes and how to use them, you can check out one of my past videos on foliage. I've done a couple on foliage for some different things. You know what? I might leave the forest just super dense, just so that we have something to walk around and look at in the actual game. Which direction is he facing? So he's facing right that way. So we can put some trees like this. It's gonna look very weird. Let's close my modes for the time being. Hit play. So it's got some trees there. Something else that I did. I might need my modes back. Where are we? Modes. Oh, backed it. Put that back in. A couple of other things. Well, there was the interactive foliage, and I can't take credit for that one. That's all Dean. I'll leave a link to his video in the description. Same with the backface culling of the the little red stormy thing. If we go back to the original map, where would I find that? There it is. Just search for minimal, because it was called the minimal default. Alright, we can save all those things. And here is the world that you saw in the video that I made. And there's a few other things going on here, so once we'll hit play, we can have a closer look. So there's the interactive foliage, as you can see. I'll leave a link to Dean Ashford's video. Same with the color there, when he goes behind stuff, so that you can still see him when he's obscured by different objects. There's the Gaussian blur here, which is all done in the post-processing. If we find the post-processing volume and search for depth of field, depth of field, it's just a matter of playing around with these values here to get a result that you like. And this can take some fiddling, but stick with it, because you can eventually turn up some very cool effects. And the final thing that I did is the colored fog, which I plugged quite a lot in a lot of my videos. It's another post-processing effect. I'll leave a link to that as well in the description below. And all of these things combined add up to this very cool little guy walking around in a very cool little world. So that's all there is to it, guys. I'm glad you all liked it. I hope this video explains things in a satisfactory way and gets you going. Remember not to use copyrighted material unless you have express permission from the copyright owner. And other than that, I guess I'll catch you guys next time.